NENOMATICA, where mathematics meets YouTube excellence. In this video, we'll learn how to divide a multi-term expression by a single-term expression, breaking down each step for a clear understanding. When dividing a multi-term expression by a single-term expression, we can divide each term of the numerator by the denominator separately. This is based on the distributive property of division, which states that a divided by c plus b divided by c equals the quantity a plus b, all divided by c. Let's look at some examples to understand this better. Our first example is 2xy squared minus 4x squared yz, all divided by 10xy. We need to apply the distributive property of division. We'll divide each term in the numerator by the denominator. This gives us 2xy squared divided by 10xy minus 4x squared yz divided by 10xy. Now, let's simplify each fraction by dividing the numerator and denominator by their common factors. For the first fraction, 2xy squared divided by 10xy, we can divide both numerator and denominator by xy, leaving us with 2y divided by 10, which simplifies to y divided by 5. For the second fraction, 4x squared yz divided by 10xy, we can divide both numerator and denominator by xy, giving us 4xz divided by 10, which simplifies to 2xz divided by 5. Now, let's combine our results to get the final answer. We have y divided by 5 minus 2xz divided by 5. So, our final answer is y over 5 minus 2xz over 5. Let's try another example. We have 15 a cubed b to the fifth minus 30 a squared b to the fourth minus 25 a cubed b cubed, all divided by 25 a squared b cubed. As before, we'll apply the distributive property of division. This gives us 15 a cubed b to the fifth divided by 25 a squared b cubed minus 30 a squared b to the fourth divided by 25 a squared b cubed minus, this gives us 15 a cubed b to the fifth divided by 25 a squared b cubed minus 30 a squared b to the fourth divided by 25 a squared b cubed minus 25 a cubed b cubed divided by 25 a squared b cubed. Now, let's simplify each fraction by dividing the numerator and denominator by their common factors. For the first fraction, 15 a cubed b to the fifth divided by 25 a squared b cubed, we can divide both numerator and denominator by a squared b cubed, giving us 15 a times b squared divided by 25, which simplifies to 3ab squared over 5. For the second fraction, 30 a squared b to the fourth divided by 25 a squared b cubed, we can divide both numerator and denominator by a squared b cubed, leaving us with 30b divided by 25, which simplifies to 6b over 5. For the third fraction, 25 a cubed b cubed divided by 25 a squared b cubed, we can divide both numerator and denominator by 25 a squared b cubed, resulting in a. Now, let's combine our results to get the final answer. We have 3ab squared over 5 minus 6b over 5 minus a. We can rewrite this as 3ab squared over 5 minus 6b over 5 minus 5 over 5. This gives us our final answer. 3ab squared minus 6b minus 5a all over 5. To summarize, when dividing a multi-term expression by a single-term expression, first, use the distributive property to divide each term in the numerator by the denominator. Then, simplify each resulting fraction by dividing the numerator and denominator by their common factors. Finally, combine the terms to get your answer in simplified form. Practice this technique with different polynomial expressions to build your skills in algebraic division. Resulting fraction by dividing the numerator and denominator by their common factors. Finally, combine the terms to get your answer in simplified form. Let's start with our first example. We need to simplify the following algebraic fraction, 6x cubed b squared plus 3x squared b all divided by 3x squared b. To solve this problem, we'll first separate the numerator into two fractions. This allows us to work with each term individually. We can split the expression as follows. Now, we'll simplify each fraction separately. For the first fraction, we can divide both the numerator and denominator by the common factor 3x squared b. So after simplification, we get 2xb plus 1 as our final answer. Let's verify this. In the first fraction, 6x cubed b squared divided by 3x squared b simplifies to 2xb because we can cancel out the common factor 3x squared b. For the second fraction, 3x squared b divided by 3x squared b equals 1, since any number divided by itself is 1. Therefore, Our final answer is 2xb plus 1. Now, let's look at our second example. We need to simplify the following fraction. 6x to the fourth power minus 3x squared minus 9x, all divided by 3x squared. Similar to the first example, we'll start by splitting the numerator into separate fractions. Now, we'll simplify each fraction individually. For the first fraction, 6x to the fourth power divided by 3x squared, we divide both the numerator and denominator by 3x squared. For the third fraction, negative 9x divided by 3x squared, we can simplify to negative 3 divided by x. Therefore, our final answer for the second example is 2x squared minus 1 minus 3 over x. We have the fraction 3a to the power of 4b to the power of 4 minus 4a to the power of 5b cubed plus 2a squared b to the power of 4, all divided by 2a squared b cubed. The first step in simplifying this expression is to break it down into separate fractions. Let's split the numerator terms and write them as individual fractions with the same denominator. We're using the distributive property of division over addition and subtraction. Now, we'll simplify each fraction by dividing the numerator and denominator by their common factors. We'll use the exponent rules to simplify each fraction. Let's calculate these exponents. For the first fraction, a to the power of 4 minus 2 equals a squared, and b to the power of 4 minus 3 equals b. For the second fraction, a to the power of 5 minus 2 equals a cubed, and b to the power of 3 minus 3 equals b to the power of 0, which is just 1. For the third fraction, a to the power of 2 minus 2 equals a to the power of 2 minus 2 equals a to the power of 0, which is 1, and b to the power of 4 minus 3 equals b. Now, we can simplify these fractions further. 3a squared b divided by 2 equals 3 over 2a squared b. Negative 4a cubed divided by 2 equals negative 2a cubed. 2b divided by 2 equals b. So our answer is 3 over 2 a squared b minus 2a cubed plus b. Therefore, the simplified form of our expression is 3 over 2 a squared b minus 2a cubed plus b. Now, let's look at our second example. We have the expression 8a to the power of 4b to the power of 5 minus 12a to the power of 6b cubed minus 4a to the power of 5b to the power of 4, all divided by 4 cubed b cubed. Just like before, we'll start by breaking this down into separate fractions. Let's split the numerator and write each term as an individual fraction with the same denominator. Now, we'll simplify each fraction by applying the exponent rules. For each fraction, we'll divide the numerator and denominator by their common factors. Let's calculate these exponents. For the first fraction, a to the power of 4 minus 3 equals a, and b to the power of 5 minus 3 equals b squared. For the second fraction, a to the power of 6 minus 3 equals a cubed, and b to the power of 3 minus 3 equals b to the power of 0, which is 1. For the third fraction, a to the power of 5 minus 3 equals a squared, and b to the power of 4 minus 3 equals b. Now, we can simplify these fractions further. 8ab squared divided by 4 equals 2ab squared. Negative 12a cubed divided by 4 equals negative 3a cubed. Negative 4 a squared b divided by 4 equals negative a squared b. So our answer is 2a b squared minus 3 a cubed minus a squared b. Therefore, the simplified form of our second expression is 2ab squared minus 3 a cubed minus a squared b. Let's review the key steps we followed to simplify these algebraic fractions. First, we broke down the complex fractions into separate terms. Then, we applied the exponent rules to simplify the expressions. Finally, we combined like terms to get our final answers. Remember, when simplifying algebraic fractions with exponents, always pay careful attention to the exponent rules and work step by step for accuracy. Welcome to our lesson on dividing polynomials by monomials. This is an important skill in algebra that will help you simplify complex expressions. Before we dive into examples, let's understand the key concept. A polynomial a is divisible by a monomial b exactly when each term of a is divisible by b. In practice, this means we divide every individual term of the polynomial by the monomial. Let's work through our first example. We need to divide the polynomial 3a to the fourth power b to the fourth power minus 4a to the fifth power b cubed plus 2a squared b to the fourth power by the monomial 2a squared b cubed. The first step in our approach is to split this into separate fractions. We'll have 3a to the fourth b to the fourth over 2a squared b cubed minus 4a to the fifth b cubed over 2a squared b cubed plus 2a squared b to the fourth over 2a squared b cubed. Now, we need to simplify each fraction. For the first fraction, we divide the coefficients. 3 divided by 2 equals 3 halves. Then we subtract the exponents. A to the fourth power divided by a squared gives us a squared, and b to the fourth power divided by b cubed gives us b. So we get 3 halves a squared b. For the second fraction, for divided by 2 equals 2, a to the fifth divided by a squared gives us a cubed, and b cubed divided by b cubed gives us b to the power of 0, which is just 1. So we get negative 2a cubed. For the third fraction, 2 divided by 2 equals 1. A squared divided by a squared gives us a to the power of 0, which is 1. And b to the fourth divided by b cubed gives us b. So we get b. Combining these terms, we get our final answer for the first problem. 3 halves a squared b minus 2a cubed plus b. Let's move on to our second example. We need to divide the polynomial 8a to the fourth power b to the fifth power minus 12a to the sixth power b cubed minus 4a to the fifth power b to the fourth power by the monomial for a cubed b cubed. Again, we'll start by splitting this into separate fractions. We have 8a to the fourth b to the fifth over 4a cubed b cubed minus 12a to the sixth b cubed over 4a cubed b cubed minus 4a to the fifth b to the fourth over 4a cubed b cubed. Now, let's simplify each fraction. For the first fraction, 8 divided by 4 equals 2. A to the fourth divided by a cubed gives us a, and b to the fifth divided by b cubed gives us b squared. So we get 2ab squared. For the second fraction, 12 divided by 4 equals 3. A to the sixth divided by a cubed gives us a cubed, and b cubed divided by b cubed equals 1. So we get negative 3a cubed. For the third fraction, for divided by 4 equals 1. A to the fifth divided by a cubed gives us a squared, and b to the fourth divided by b cubed gives us b. So we get negative a squared b. Combining these terms, we get our final answer for the second problem. 2ab squared minus 3a cubed minus a squared b. Let's visualize the process to better understand how division works in these examples. When dividing polynomials by monomials, we can think of it as distributing the division across each term of the numerator. The key steps are: first, split the fraction into separate terms. Then, for each term, divide the coefficients and subtract the exponents. Finally, combine the simplified terms to get your answer. Let's talk about some common mistakes to avoid when dividing polynomials by monomials. First, remember to divide each term of the polynomial by the monomial, not just the first term. Second, when dividing variables with exponents, we subtract the exponents, not divide them. Third, don't forget the signs when recombining terms at the end. In summary, to divide a polynomial by a monomial, first, distribute the division to each term of the polynomial. Second, for each term, divide the coefficients and subtract the exponents of the variables. Finally, combine the simplified terms to get your answer. With practice, you'll become more comfortable with this process. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.